What we're going to learn on this video is how to multiply and divide positive and negative numbers. In other words, how to multiply and divide integers. On the way, we're going to create some intuition for why these rules exist and also give you some insight to common mistakes students make. Now, there's a formula that people traditionally just make students memorize, and that is that a positive number times a positive number is equal to a positive number, and a negative number times a negative number is equal to a positive number. So if the signs of the two numbers being multiplied is the same, the answer is positive, and if the sign of the two numbers being multiplied is different, the answer is negative. Now the first question is, why is that so? So if we look at 2 times 3, something that we understand, we know that that's equal to 6. The reason why it's equal to 6 is because 3 plus 3 is equal to 6. Now, using this same pattern, if we have 2 times negative 3, what's happening is that we have negative 3 minus another negative 3. So if I borrow $3 and I borrow $3, I should owe someone $6. Now, just using this table, we can see that a negative times a negative should be a positive number. So this should be a positive 6. And a negative number times a positive number should be a negative number. Go ahead and pause this video and try these problems on your own. Now that you've had a second to try these problems, let's do them together. A negative times a negative is a positive number. A positive times a negative number, right? The signs are different, should give you a negative number. A negative times a positive number should be a negative number. A negative number times a positive number should be a negative number. A negative number times a negative number should be positive. And a positive times a positive should be positive. And this is something we knew even before we started watching this video. Nothing has changed. 4 times 5 is still 20. Now, just know that these rules also work for larger numbers and also work for decimals and fractions. So let's just look at this problem over here, 12 times negative 42 and negative 12 times negative 42. Both of these problems require you to multiply 12 and 42, so let's do that. So then when we add these together, we get 504. So let's just remember our rule. A positive number times a negative number is a negative number. And a negative number times a negative number is a positive number. Okay. Now let's work on exponents. This is where students start having a little bit of problem. So before we dig into exponents, let's look what happens when we multiply a bunch of different factors. So if I have negative 2 times 3 times negative 4, what I first do, and I can do this in any order. I can multiply the 3 and the negative 4, or the negative 2 and the negative 4, or the negative 2 and the 3. In this case, I'm just going to go left to right. But because everything is separated by a multiplication, you can do them in whatever order is easiest. So a negative 2 times a positive 3 is a negative 6, and then we'll bring down everything else. A negative number times a negative number is a positive number. Now, let's look at how these exponents work. What this means is bring down the negative 3, and you want to multiply it twice. We have 2 factors. A negative number times a negative number is a positive number. Now, this is a little bit different. This is the one that's a little tricky. It's the kind of problem that shows up in your LSAT law degree test, or your SAT, or your ACT. Now, before we get to this problem, let's look at a different problem that looks like this. If I was to ask you to compute this problem, most people would be comfortable saying, oh, that's 10 minus 3 squared. And in your mind, you would say, that's a subtraction. That minus is not connected to the 3 squared. So you would look at that and go, oh, that's 10 minus 3 times 3. That turns into 10 minus 9. Now, if we were to cover up the 10, you could see that negative 3 squared is negative 3 times 3 is equal to negative 9, because this negative is not connected to the 3. We don't see it when it's like this, but we easily see it if we put a number in front of it. So when I'm looking at this problem over here, you have to be very careful and know that that negative is separate from the exponent. And if we do orders of operation, we always do exponents before multiplication. So that's why we expand the 3 squared first, and then this turns into a minus 9. Okay. In this one, what we're doing is we're multiplying negative 2 3 times. Negative 2, negative 2, negative 2. Negative 2 times negative 2, when we just look at this pair, that turns into a positive 4, which then turns into a negative 8. When we do this problem, see how there's no parentheses? That negative is not connected to that 2. So we expand the 2 3 times, and then we'll multiply the first 2 together. We get negative 4 times 2 is equal to negative 8. And then this will follow the same pattern. This time we're going to have negative 2 4 times. Now, because each one of these is separated by the same operator, addition, I can do these in any order that I like. I think the easiest way is just to pair these up. Negative 2 times negative 2 gives me a 4, and negative 2 times negative 2 gives me a positive 4, and 4 times 4 turns into 16. Now, over here, we're going to expand that 2 4 times. Now remember that negative, let me put a little line up here, is not connected to the 2. So again, we can multiply these two, multiply those two. We can get negative 4 times 4, which turns into a negative 16. Okay. Now let's look at division. Division follows similar rules to multiplication. When you divide two numbers and the signs are the same, you get an addition, you get a positive number. And then when you divide two numbers that have a different sign, your answer becomes negative. So in this case, we have a positive divided by a negative. This turns into a negative number. 12 divided by 4 is 3. In the same case, we would get a negative 12 divided by 4. This turns into a negative divided by a positive is, again, a negative. And over here, since the signs are the same, a negative divided by a negative is a positive number. I'll get a positive 3. Now, a common question that'll come up later in class is that people will ask me, does it matter when I have a fraction if my negative's on the top or the bottom or in the middle? And the answer is it doesn't. The reason why is that if the negative's in front, it's disconnected from the number, and this is equal to a minus 3. And we could see that whether the negative is on the bottom, the top, or the middle, each one of these have exactly the same answer, negative 3. The only thing you can't do is split the negative into two pieces. This is the only one that's not equivalent to this, this, and this. So be careful when you're doing your algebra later in the semester. Okay. Now comes my favorite problems. 0 over 3 and 3 over 0. Let's understand what these two things are, because this is something that's come over and over in our class. Now, if I gave you something that looked like 4 over 2, you would say that's equal to 2. Why? It's because 4 divided by 2 is equal to 2. So a fraction is simply a division. 0 divided by 3 turns into 0. Now, another way of looking at this is that if I had 1/3, that means that I have 3 balls, and I give you 1 ball. And it's possible for me to have 3 balls and for me to keep all of them. So this is possible. In this case, I gave you 1 ball out of 3. In this case, I gave you 0 balls out of 3. Now, this is where it's a little more confusing. Another way to think about this is that I can treat this like long division. 3 goes into 0 how many times? 3 goes into 0, 0 times, like 3 times 0 is 0, and I get 0 as a remainder. Okay. Now, using this same logic, if I use long division, okay, we're seeing that the bottom number goes on the outside, the top number goes on the inside. If I ask you what number times 0 is equal to 3, there is no number. If I put a 3 here, I end up 3 times 0 is 0, and I end up the same place I was. I haven't made any movement. It's impossible, right? If we think of this in terms of the 1/3 example, if I have 1 ball out of 3, right, I can color 1 ball out of 3, but it's impossible to color 3 balls if I have no balls. So in this case, we say that this is undefined. Now, depending on what book you're using, sometimes it'll be not a number. Sometimes people will say it's no solution. Basically, what we're saying is that this is impossible. It is possible for me to give you $0. It is impossible for me to give you 3 divided by $0. That number doesn't exist. Now, if this video was helpful to you, please like and subscribe it so other people can find it. Thank you.